Welcome everyone. My name is Aisha Mickey and we are here today for a technical take on More Than Mesh, our webinar. Our CTO Maarten Egmond will be presenting the presentation. We'll start with that, and after that one of our Wi-Fi engineers, Mattia Tore, will join him for the Q&A. So let's not wait any longer and get to the presentation.
Thank you, Aisha, and welcome everyone to the webinar. So let's get started. And as Aisha said, I'll start with the presentation, but I've divided it up into two parts. First, to talk a little bit about mesh in general and what we actually need, and then go in a little bit more detail on Wi-Fi Alliance EasyMesh standard, what it does and what it does not do. Then in the second part, I want to talk to you a little bit more about the more part in More Than Mesh. And I've taken two parts to this, 2 points. To talk a little bit about the user experience in wider context, and also to ensure that the operator remains in control. And why those are relevant, you will see when we get to the presentation. And as Aisha mentioned, at the end, there's time for a Q&A session. So part one, let's talk about mesh. And mesh is actually somewhat surprisingly complicated concept. So first, it's good to understand what is actually a mesh network. And if we don't know what something is, or we're curious about the definition, one of the common sources these days is to go to Wikipedia and have a look what it says. And Wikipedia has a definition, and it says, a mesh network is a network topology in which the infrastructure nodes connect directly, dynamically, and non-hierarchically to as many other nodes as possible and cooperate with one another to efficiently route data from and to clients. So it's a long definition, there's a lot of stuff in there. But it is about nodes connecting, it's about dynamics, and it's about connecting to many other nodes that you would like to. So if we have a look at some example topologies in a network, you could ask yourself, which ones of these are mesh networks and which you would consider not to be mesh networks? And it's an interesting question. And in fact, if you're a purist or a philosopher, you may not agree on what we see here, even based on that definition. Because, for example, if we look at this one over here, this is clearly a mesh network because it's fully connected, it has 6 nodes, and all the nodes are connected to all the other nodes. I guess technically we don't know if it's dynamic or not, but this is a pretty clear picture. I think everybody would agree this is a mesh network. Now, on the left-hand side, we see the same nodes in the same place, and clearly there are fewer connections. Most obviously, you might call this a ring topology, but is this a mesh network or not? And from the picture, you can't actually see, because if the intent is to connect to as many nodes as possible, then maybe the opposing nodes cannot see each other, and so they cannot connect. So maybe this is as many nodes as possible in connectivity already. So it could be a mesh network, but it doesn't really look like something that we might typically call a mesh network. And then the other example is if you have a network that is only 1 node or maybe 2 nodes. If you have a 2-node network and they are connected, there are of course as many nodes as possible connected to each other, but there are only 2, so you can equally argue it's just a simple network as well. So mesh is a little bit complicated, but in general, for me, it is also a lot about the intent here, that it's dynamic, it's non-hierarchically connected, and it is as many nodes as possible. That's my takeaway here for what is a real mesh network. Now, if we look at an example of a mesh standard, because these exist, and this is probably not the only one, but it's a very interesting one. Because 802.11 that everybody knows from IEEE as the Wi-Fi standard, there is a standard 802.11s, which is Wi-Fi mesh. And this was standardized already in 2011, so it's now 10 years ago, so quite a long time. It fits very well in the 802.11 suite of standards. And so you might wonder, why do we not just use this, right? Because it's in fact not so common. And what we see is that despite the fact that this is standardized as part of 802.11, many proprietary solutions exist today to do mesh or mesh-like networking. There's very little interop in the industry. And you can ask yourself, why is that the case? One obvious reason might be that we don't need mesh, perhaps. In which case, of course, the whole standard is not relevant. But maybe something else is going on. And in fact, it's that latter, that something else is indeed going on. So if we look at some of the downsides to 802.11s, why it's not adopted so widely, first of all, it's good to understand that while it is dealing with the mesh network itself, it does not address how to actually set up that network and how to manage it. So it's very easy. Once the network is established, it will work. But how do you get there? And we all know when we are doing home networks with end users, it's not so trivial. You can't just expect them to go to CLIs or other complicated ways to manage their network. They're not network engineers. So that needs to be addressed, and the standard does not do that. Also, one of the problems with 802.11s, or limitations, I should say, is that every link is on the same Wi-Fi channel because they are talking about real mesh. And in order to connect everything to everything, everything effectively needs to be on the same Wi-Fi channel. And we know from long ago, when there were repeaters in the market that receive a signal on one band and send it back out on the same band, it greatly reduces the overall capacity of the network. Every time you cut the airtime that's available in half. So if you have one or two nodes, maybe it's not a big problem yet, but if you have a couple more nodes, it starts to become a real problem. And then finally, one of the downsides, it's Wi-Fi only. Of course, it's a Wi-Fi standard, so it makes sense. But it's a little bit a pity because this standard does not deal with the mix of wireless and wired links that you typically have in a home environment. Consumers want to have reliable links for some equipment. Maybe in some homes you have structured cabling, Cat cabling already installed. Then you would like to make use of that as much as you can. And 802.11s kind of also puts that a little bit out of context. So it doesn't really optimize very well for this kind of scenario. Now, with all those downsides, you might just think, well, maybe we should just forget about it. But I don't agree. I think we still need something. But we need to go back to the basics and first talk a little bit about what we actually need, because we've seen a lot of requests for mesh in the network. And it's not always clear what we actually need, because as we just saw, a real mesh network can be quite complicated, and maybe it doesn't even cover everything we need anyway. So if we go back to the core, what we actually need. And first of all, I would say what we need is to consider that people deserve to use the services that they've subscribed to comfortably at home. That's what makes our heart beat faster, if we can get people to enjoy their services. But this is a very vague statement, right? It's very nice to say, yeah, it should just be very good. So this is not something we can build. So we need to ask ourselves, how can we build this? How can we achieve this? And so the next step, if we try to go a little bit more detail, we might say, okay, it's all about providing good Wi-Fi performance and good user experience at home. And the user experience, of course, for the end user, but also in our case for the operator. Okay, it's maybe a little bit better, but it's still a little bit vague. What is good Wi-Fi performance and user experience? So we again can ask ourselves the how question. How can we deliver good Wi-Fi performance? So if we go one step deeper, then I would say this is all about sufficient bandwidth provided anywhere in the home with simple management and not locked in, important for the operator. Now, this is still kind of a set of problems, right? This is not a solution, but it is at least much closer to things that we can actually address. And if we look at this step by step, then what we find is we could ask ourselves, well, how much is actually sufficient bandwidth? What is that? So this problem is largely addressed as of today with the 802.11ax standard, or Wi-Fi 6, and the upcoming 6 GHz band Wi-Fi 6E. That will ensure that we have what we will know for a couple of years at least until Wi-Fi 7 comes, to be sufficient bandwidth and reliable bandwidth. Great. So that problem is more or less solved. Then the next step is, well, where is anywhere? We talk about anywhere in the home, but what do we actually need where, and how do we get there? So this problem is addressed by having multiple access points in the home. Not a lot of access points, people don't want too many boxes in their home, and they all cost money and they're difficult to install and so on potentially. So you don't want to have many access points, but you need a few. We know these days that whole home coverage, unless you live in a small apartment, cannot be achieved if you just have one single access point in the home. So we need a couple. And this is what we kind of call mesh, and I've put mesh in quotes here because it's not necessarily saying that we need a real mesh network with all the complications, but we need to somehow manage these multiple access points so that it behaves as a single network and the end user does not have to be afraid of where he is in the home. Then the next part was about simple management. So what does that mean, simple management? Well, this is all about things like onboarding, automatic synchronization between the access points, being able to do diagnostics easily, and many other things to make it simple, again, for both the operator and the end user. And this is kind of what we see a lot where the more needs to come in. It's not just mesh networking that we need, but we need a lot more than that. And then finally, just about this not locked in, which on the one hand perhaps sounds very obvious, especially if you're an operator, you don't want to be locked into solution. But what does that mean? Well, of course, here in the mesh networking, it means that you need to have multi-vendor interoperability, because now when we have multiple access points in a single home environment, maybe not all the access points belong to a single vendor anymore, because you don't want to be locked in, and so on. And how to achieve this one is by standardization. We need to have a standardized solution to achieve the multi-vendor interop so that you can pick and choose what you want, or the end user can pick and choose what they want, what works for them. And the only way to achieve that is by standardization. So now we have a little bit more clear picture of what we actually need. And some of it is already taken care of it. Some of it we can address by mesh, and we need a lot of more as well. And it all needs to be standardized. So now let's have a look at the Wi-Fi Alliance's EasyMesh. Where did this come from? So the Wi-Fi Alliance made a standard back in 2018 that they called the multi-AP standard. And of course, multi-AP is not so sexy a name, so it doesn't stick so well. So when they launched their certification program, they called that EasyMesh. And we have a couple of versions of the standard by now. So mid-2018 was the first release, 1.0 multi-AP, and the certification was done under EasyMesh R1. And then there's a couple more versions, and you can see that by standard number 3, version number 3, end of last year, the Wi-Fi Alliance also realized that the industry was picking up on the EasyMesh name. It's a very good name. It sticks. And to bring some order in their way of working as well, they renamed the standard officially to EasyMesh as well. So now we can just talk about EasyMesh. We don't have to worry about it. What you can also see here is that the releases come about every year or so, and you can see that they've been growing. Of course, it doesn't matter necessarily how many pages there are, but it gives you a clear indication that the first standard was a little bit limited, and they've been expanding greatly on its capabilities in the newer releases. EasyMesh 4.0 is not yet formally released, but we actually expect that to happen later this month. So that's very nearby. And we already know a little bit about what's in it and how that will affect us. So overall, it's clear that the EasyMesh standard is still fairly new. It's only 3 years old. And as you know, sometimes it takes a long time for standards to be adopted after they're released. So it's still fairly new, but the uptake is already increasing quite rapidly. More and more people are talking about it. People realize that this is what they want. And so we see a lot of things happen in this area. However, it is good to understand that there are some paper launches out there as well. Some of the vendors that have proprietary solutions today, they really are happy with the lock-in that they've created and that customers can't so easily pick other solutions. So they do paper launches. They say, yeah, EasyMesh is great and it's coming and so on, but they downplay it a little bit and they will probably delay their implementations. And I don't think that's a particularly good thing. So be aware of that. Now, if we look at the main principle, how does this work, EasyMesh? And I will take you through the diagram you see on the right. It's a little bit complicated. I took it from the V3 spec, but I'll explain to you a little bit as we go along what we see. So the first thing to understand is that with EasyMesh, there are two main roles defined in this multi-AP network: the role of agent and the role of controller. The agent basically provides methods to control the access points Wi-Fi interfaces and to provide information to the controller. So it's not really a smart device in itself necessarily. It is providing methods to let the controller control it. And as the name implies, the role of the controller is the one who actually controls the operation of the multi-AP network. So if you look at the diagram here, you see that we have an uplink somewhere in our network that goes out of the home. And then we have here four multi-AP devices that are connected in various ways. You can see here the lightning marks mean wireless connection. So these two are connected over a wireless interface, these ones as well. Here's one we have connected over an Ethernet cable. And then you can see there are various clients here, in this case, three things that look like a mobile phone or a tablet and a laptop connected, of course, these days all wirelessly to the network. Now, the next part is that every AP that you see is an agent because they all need to be able to be controlled, but there can only be one controller, which makes sense because if you have two captains on one ship, it typically doesn't go so well. So every AP is an agent, but there's only one controller. And typically the controller is done by the gateway. So we have the WAN uplink. This is likely the gateway. Then we have here a couple of mesh extenders. And the gateway is the most logical place to put the controller. Because you know there's only one gateway, you know where it is. It's a central device. It's the one that is mostly fixed and always on and so on. So it makes a lot of sense. But it is good to remember that the Wi-Fi, the EasyMesh standard does not mandate which one should be the controller. It leaves it open for discovery and what you might want to do in your deployment. And for example, it can also mean that the controller could be a device that has no Wi-Fi by itself. Flexibility. And lastly, because EasyMesh is a standard, so what EasyMesh standardized is largely the communication between the agents and the controller and what agents can do. And that is how the multi-vendor interop can be assured, because if all these devices talk the same language and work in the same way, then of course they will work together happily in a home network, even if they are from different vendors. So this is kind of the main principle. And you also see here the roles of the controller and the agent. So you can see this one has the controller and the agent role, and these ones only have the agent role in the network here. So that's kind of how it works. Now let's go back just briefly to the comparing the releases. So we said there were 4 releases, with R4 coming out shortly. And let's have a quick look at what's in there. I don't want to go through all the details. We can probably talk about that for a long time now elsewhere, if interested. But as you can see, a lot of stuff has been added over time. There's new stuff coming. And some particularly quite interesting gaps have been resolved between R1 and R2. So for example, things like the channel scan, which of course is very interesting to understand a little bit more what the wireless environment looks like. Agile multiband support to be able to do band steering as well, and not just access point steering. And more information, the data elements for diagnosis purposes, for example, and a couple more things. So the difference between R1 and R2 is pretty significant. And then after that, of course, it still gets better. But you can also see in R3, we have DPP-based onboarding, which I guess everybody knows WPS. It's been in from the start. And DPP is these days called Easy Connect. So it's a new protocol also from the Wi-Fi Alliance to make onboarding even easier. And you can see they added this in R3. And there are some other things which are kind of not core Wi-Fi or core mesh activities, but still quite relevant in the total picture. So the use of this standard is also increasing. And then finally, you see the O's marked on R4. So Wi-Fi Alliance also realized if we make everything mandatory, it becomes very difficult to certify. And maybe not every device needs to provide every capability. So they have these optional features, or they call it optionally mandatory, to be able to deal with that a little bit more flexibly as well. The releases have been growing over time. But what is very important to understand here is even though this one talks, for example, about the all-important client steering, there are some footnotes that we need to observe with many of these things. And footnotes is basically that EasyMesh still needs a brain. EasyMesh is a great standard, but it does not decide on how you do the client steering in the end. It provides the means, the APIs and so on, to be able to do steering, but it doesn't say what the algorithm should look like to do the steering. This is left for companies to implement, to innovate on. It's still an area of a lot of active research to be done. So it makes sense, but it is important to realize that. Now, to kind of conclude a little bit on EasyMesh, a little bit of summary on what it is and is not, because we've seen it's kind of mesh, but maybe not entirely. It's doing some other stuff that's not related to mesh. So maybe a little bit in summary, I would say, first of all, interestingly enough, even though it's called EasyMesh, it's not actually a full mesh. We saw at the start, a full mesh is about having more connections, multiple connections, as many as possible. And in fact, EasyMesh is doing only a tree topology. Now I've put a happy smiley here in green because we are building products for a home environment. We are not trying to hook up airports and stadiums and large venues and all these things. We are looking at a home environment. And for a home environment, a tree topology is fine. We have maybe 2-3 nodes. So you could even argue whether this is mesh at all or not. So having a tree topology is fine, and it makes the management of the mesh a lot simpler as well. So you don't really lose any capability, you just make life easier. And it's one of the reasons why EasyMesh as a standard has become adopted and 802.11s much less so. And the second part, as we saw, there's a standard 802.11s, and this is not compatible with 802.11s. And I've also put a happy green smiley here because I think this is also good, because 802.11s suffers a lot from having all the connections on the same channel. So you basically are never left with good enough bandwidth in your home, even if you're on Wi-Fi 6 and 6E probably. So EasyMesh is a lot more flexible with bandwidth and optimization, and it can use both the wired connections as well as multiple radios in an access point on 2.4, 5, and later 6 gigahertz. So it's just a lot better in practice. Then we have a couple of more things that are a little bit not so much a positive or negative, but just something to be aware of. So firstly, EasyMesh does not do the steering by itself. There needs to be an algorithm in the controller, and this could be different between different implementations. So not necessarily good or bad, just something to be aware of that you need to pay attention to this. Then we have the onboarding, very important for end users to be able to add nodes if they are not happy enough with their Wi-Fi and they need a bit more coverage. So EasyMesh addresses onboarding partially. As I mentioned, they started with WPS. It's a pretty nice, simple way. Press a couple of buttons and you get linked up. But they've expanded with the Easy Connect standard in R3, which deals with things like scanning QR codes or NFC connectivity and so on to make it even easier. The point here to make is that while EasyMesh addresses the onboarding from the Wi-Fi point of view, there is a bit more to the whole user experience to make it easy. And so you do want to make sure you also consider end-to-end user experience, or the user experience in the wider context that I will talk about a little bit in a minute. And then what is important for service providers especially is that EasyMesh does not standardize the northbound connectivity. So inside the home network, the connectivity, the messaging is all standardized, but northbound, to make sure that the operator can manage the network, this is not a part that EasyMesh addresses. So we still do need other standards. And for example, one of the most common ones to manage devices for service providers is TR69 as of today. Also, and maybe this is an obvious one that nobody would confuse, but perhaps still important in some context to understand, EasyMesh does not improve things like signal strength, the Wi-Fi quality, or coverage by itself. Because simply put, it does not affect the hardware capabilities of the device. It does not change any of the regulatory limits that we have in Europe and worldwide that we have to cope with. and it doesn't change device placement. Of course, ultimately the device is still placed where the end user puts it, and EasyMesh has no direct influence on that. So a couple of good points, a couple of things to be aware of, and that's a little bit the summary of EasyMesh. Now, let's get to part 2 and talk a little bit about the more in more than mesh. So, as I said, EasyMesh is great, but it's only one ingredient that we need for the total network. EasyMesh provides a standardized way to set up and use an interoperable multi-IP network, and it's for sure something we need. And after its initial release, where R1 was still a little bit limited, it has now reached maturity. I think R2 is great, and then it gets even better from there. Now, beyond just doing the mesh part, it also offers functionality related to this, to Wi-Fi, such as the onboarding and a base for diagnostics. And these cover some of the more that we need, but not everything. And in my opinion, what is important especially is that the move from proprietary solutions to standards is the only way forward. We have to adopt standards because that's the only way to get buy-in from end users. It's a disaster if you tell them to, sometimes you might give them an access point for free or lease constructions. But if an end user buys equipment and you then tell them a year, 2 years later, they have to throw everything away, it doesn't work together, or they have to replace it, they're going to lose belief. They're going to go to a different provider that might have something better. And also, this is the only way for the industry as a whole to scale. So it's clear that when there is new technology, that proprietary solutions evolve for innovation and to see what works. But then standards come. And while the proprietary solutions can stay in their niches, they hold back the market as a whole. Once standards are introduced, and we see this in all the industries, the biggest example related to our industry, of course, is the internet. The open standards that are the basis for the internet is why we are where we are today with everything. And so having standards is the only way for the industry to scale and to get ahead. However, it is also clear that EasyMesh leaves some room for better user experience in the wider context of the connected home, if we don't just look at the Wi-Fi part. And also that it focuses on end users instead of operator needs, which we do need to address, of course, as well. So let's have a look first at one example of this wider context, and that's our 3-in-1 functionality. So if you saw the product launch of our Pulse EX600, then you already saw this explained a little bit. And basically, if we look at this from a home network, you have different functionality. So you have a router or a gateway device, and you have your mesh extenders, and these provide different functionality, clearly. But even though they are providing different functionality, there's not always a technical reason why you need different boxes for this. The underlying hardware is often capable of doing more things with a bit of care and so on. And if we could use the same box for these purposes, and especially if this can be done automatically, right? We don't want the end user or even the operator to have to configure these devices manually and deal with all of that. So if you can use the same box automatically, that would simplify the user experience greatly, because they don't no longer have to figure out that this is the gateway device, they need to connect it over here, this is an extender, they need to connect it after that, and so on. They just connect the boxes however they want, and it works. Of course, great idea, but how do you make that work? It's not something that happens automatically if we don't put our work into this. And so our Pulse EX600 automatically detects the uplink and adapts accordingly. And just a couple of points to how this works. So first of all these devices are typically driven by DHCP. They request an IP address upstream. And if they get certain DHCP options, then it can just tell them what role they need to play. And it means that the operator can send a DHCP option for whichever the first device is at the gateway. And then the Pulse EX600 devices can downstream send different options to make sure that all the other Pulse EX600s become or stay as extenders. Also, if DHCP options are not available in some cases, if the ISP, for example, is not under full control of the DHCP server, then it can also look at IP address classes see public versus private IP addresses, and use that as a basis. Now, of course, you might say, yeah, but these days we ran out of IPv4 addresses, so there's a lot of carrier-grade NOT going on. So of course, we are configurable to be able to cope with that, set up different ranges and so on. No problem. And we are even more flexible to be adapted to specific deployments. And as always, you can even disable this if it doesn't work for your deployment, if you don't like it, or if you have other reasons. So it's a very flexible solution that in most cases works automatically. And if there is fear that it doesn't work automatically in a particular situation, it can be adapted or it can be disabled as well. So this is how we can provide even better user experience with the 3-in-1 functionality to deliver products that the user can just connect and not worry about anything. Now, the other part to look at here is the operator needs. EasyMesh is really aimed towards end users and consumer home networks. It doesn't address the operator. And operators need insight into the network, and also they need to be able to control the home network, because one of the unique selling points or the differentiators that the operators have versus the Googles and the Amazons that are trying to take part of this market as well, is the fact that they have a good relationship with the end user, they have the trust of the end user, and they can actually provide support, which these big companies are not set up to do. So the broadband forms TR69 is the standard for this. There's really only one clear way. And this is supported with evidence by the fact that these days there are far more than 1 billion CPEs out there that are supporting TR69. It's not just a niche standard, it is the most widely adopted management in this area. But the home network is getting more complicated. Years ago, you might still say, I have a gateway, it's one device, it has Wi-Fi, and that's it. And you need to manage one device. But now we no longer need to manage one device, we need to manage the home network. We have multiple devices, we add extenders, Wi-Fi and mesh have additional requirements. So we need some changes as well. And the first change is the most obvious one, perhaps. We need a data model update to cover the multi-AP network. And this is in fact something the Broadband Forum is working on as part of the TR181 data model, which is the standard data model, to make sure that EasyMesh is covered and the multi-AP network is represented properly in the data model. And while we wait for this standard, this is also something that shouldn't take too long. But while we wait, we can, of course, deal with that in the meantime. But that's very important to have. Also, we need always-on connectivity. So TR69 is originally designed to be an on-demand connectivity or periodic connectivity that the CPE every few hours or whenever contacts the ACS to exchange information. But with Wi-Fi, we want to be able to continuously gather information on Wi-Fi, how it's performing, to be able to proactively troubleshoot and so on. So we want to move towards an always-on connectivity model, so we can exchange information, we can exchange more information, and we can exchange it more flexibly for things like analytics. And then finally, and this is also a little bit of preparation for additional services that you might want to add to the network and to the products over time. There should be a protocol update so that multiple parties can control the same device. In the basis, if you just look at the home network in this context, it's already to help share the management between end user and operator better, where TR69 is really just an operator management. But as I said, it will become also very interesting when we want to prepare for providing additional services later. And some of those services might relate to the Wi-Fi behavior and the controller for EasyMesh and so on. So if multiple parties can control the same device and cooperate in their management, then it's no longer the case that, like with TR69, everything has to go through the ACS. And if you want to do something new, every time you need updates on data models and implementations, here things can just coexist side by side. Now, how do we do this? And how we do this is by adopting the new USP standard, otherwise known as TR369. This is a great new standard. I won't go into all the details today. There's not enough time for that. Do have a look if you're interested in the Broadband Forum, or come talk to us in other areas. This is a great standard to support and to help resolve a lot of the limitations we have today and prepare us for the future. So in conclusion, more than mesh, that's what we want. And what we saw is that we need a solution that provides sufficient bandwidth across the whole home, with simple management for the end user and for the operator. It needs to be interoperable, and we really don't want to have a lock-in anymore. The ingredients for this are the Wi-Fi Alliance EasyMesh standard, which provides a lot of a big part of the puzzle, but it's not enough by itself. We also need the broadband forum to add the critical operator control via TR69 and USP coming up. And then finally, we need a company like Genexis, where more than mesh adds the rest and ties everything together into a real product and a real solution. So in the end, this is what makes it simple to use, flexible in operation, and built on open standards. And that's how we can give the end user a great experience while we keep the operator in control. That is my story, and thanks to the audience.